Alright, let's get started with our overview. What is Rhino? Which corresponds to Chapter 1 of the Rhino Training Manual Level 1. I recommend having the PDF open on another monitor or nearby so you can follow along as we go, and you'll find links to download the training manual and the auxiliary models I'll be using in this series right in the playlist description. What is Rhino? Rhinoceros is 3D modeling software that can be used in a variety of ways for very different purposes. It is primarily a surface modeling tool, but has many related functions as well. Many users use only a small portion of what Rhino has to offer, while others need and use a lot more. It depends on what the individual user is trying to accomplish with the application. Even very experienced users can find new and useful tools of which they were previously unaware. In this introduction, a broad overview of various elements that you will encounter while using Rhino to get your work done is provided. Object types. What does Surface Modeler mean? Rhino has tools to create and edit several different types of objects, of which surfaces are one. A surface in Rhino refers to an infinitely thin, infinitely flexible, mathematically defined digital membrane. You'll notice that I've modeled all of the various object types that we'll be covering in this overview. Let's begin with surface. Surfaces are represented on screen by either some outline curves plus some interior curves called isocurves, or by a shaded picture which makes a surface appear to have some substance and to show light and shading. How surfaces are painted on the screen is dependent on the display mode in the viewport and does not affect the surface in any way. The important thing to remember about surfaces is that they are defined with great precision at every point by complex math formulas. They are not approximations. Polysurfaces. Rhino also has objects which consist of two or more surfaces joined together. This is possible when the edge of one surface is located very close to the edge, within tolerance set in the file, of another surface. We call joined surfaces polysurfaces. Since there are some restrictions on editing polysurfaces, Rhino makes it very easy to extract the individual surfaces from polysurfaces and join them back together. Let's continue now with solid. We have already said that surfaces are infinitely thin. They have zero thickness. However, any physical object will have some thickness, not zero. If you need your objects to have thickness or volume, there are two ways to accomplish this. The first is to make sure the surface closes on itself and has no openings anywhere. Spheres and ellipsoids are examples of this type of surface. The second method is to join enough single surfaces together to enclose a space. Again, with no openings, not even very small ones. A box is an example of this type of object. We call these objects solid. But it is important to remember that there is nothing inside of them. Allow me to demonstrate. Here you'll see I've exploded a rectangular prism, and you'll see there's nothing inside of it. They are volumes in space enclosed by the infinitely thin surfaces. If you remove one side of the box and look inside, you will see the back sides of the 5 surfaces. Next, let's discuss lightweight extrusion objects. Another object type that is related to a polysurface and a solid is the lightweight extrusion object. Lightweight extrusion objects use less memory, mesh faster, and save smaller than the traditional polysurfaces. In Rhino 8, commands like box, cylinder, pipe, and extrude curve, all which you see modeled here, create lightweight extrusion objects by default. Next, let's review curve. Another object type that is related to a surface is a curve. In Rhino terminology, the word curve includes lines, polylines. Think of these as series of straight line segments strung together end to end and joined. Arcs, ellipses, circles, or freeform curves that are generally smooth. Polycurves are curves made up of two or more curves joined end to end. Separate polycurves into curves by using the explode command. You can use curves as inputs for creating and editing surfaces. For example, you can trim a surface or polysurface with a curve, but they may be useful in themselves as well, as in making a 2D drawing of a 3D model, or as reference or construction geometry. You can derive and extract from surfaces. For example, all surfaces have edges, and it is possible to extract an edge curve if needed. You can also extract surface isocurves. Let's conclude the overview with Polygon mesh. Rhino also creates, edits, and otherwise uses polygon meshes. Polygon meshes are sometimes used to depict the same type of objects as surfaces, but there are very important differences. You'll notice in my interface I have modeled a sphere surface on the right-hand side and a mesh sphere object on the left-hand side. Polygon meshes consist of a number, sometimes a very large number, of points in space connected by straight lines. These straight lines form closed loops of 3 or 4 sides, that is, polygons. One important thing to know about polygon meshes is that the 3D data only exists for these points or mesh vertices. The space between these points is not considered. Dense meshes are more accurate than very loose ones, but not as accurate as surfaces. Although meshes are important in 3D modeling, initially we will not discuss them. For instance, if you look at a surface in a shaded viewport, what you see is actually a polygon mesh derived from the surface for the purposes of making a nice image on screen. Typically, you will export mesh data for rapid prototyped parts. Deriving accurate meshes from surface models is important, and Rhino has a number of tools to help accomplish this. That concludes our overview for object types. If you found this helpful, go ahead and subscribe so you don't miss the next tutorial in the Rhino Training Manual Level 1 playlist. Thanks for watching. I'll see you next time.